Welcome to our lesson on the geometric progression, which is sometimes abbreviated as GP. So we'll have about 4 or 5 different components of the geometric progression, which we're going to look at. The first component is the common ratio. The common ratio of a GP is designated as R. The common ratio is designated as R. The second component is the first term. So, like for the arithmetic progression, the first term of the GP, is designated the first term is designated A. Then the third component is any term on the GP. So the nth term, any term on the GP. So the nth term, which may be designated as Tn, this is given the formula A times R, which is raised to power n minus 1. The common ratio is raised to the power n minus 1. The fourth component of the GP is the sum of a given number of terms. So, sum of a given number of terms that are on the GP. Now, we have 2 or 3 different expressions of the sum of a given number of terms. This depends on the value of R. So, the first case is where R is greater than 1. So, if R is greater than 1, then the expression for the sum of a given number of terms will be A multiplying R to the power n minus 1. This is the case where R is greater than 1. This particular case is where R is greater than 1. The second scenario is where R is less than 1. If R is less than 1, the expression changes. We change the position of 1 and R. So you will notice that we are just changing the position of 1 and R, because if R is less than 1, then that is what we are going to subtract from 1, since it's smaller. So the formula is almost the same. The only difference is how we go about it when R is smaller than 1 or greater than 1. So then the fifth expression is a derivation of the case where we have R which is smaller than 1, which we call the sum to infinity. The sum to infinity simply means that the R has become increasingly small. It has become increasingly small so that it is almost 0. So that is what we call the sum to infinity. The sum to infinity, this is written as S to infinity, sum to infinity, and when r becomes increasingly small, it is approaching 1. The numerator is approaching 1, which means we'll just remain with the first term as the numerator of our fraction. The numerator will be the same as just the first term, and then the denominator will be the difference of 1 and the common ratio. So this is strictly for situations where r is very small, and we are considering small to the infinity value. So these are the important components of the GP. Now, the geometric progression is a sequence or a list of numbers in which consecutive terms have a common ratio, meaning when we divide two numbers that are following each other in the sequence, we'll get the same answer, we'll get the same quotient, and that quotient is the one that we call the common ratio. So once we have a list of numbers given, and we divide consecutive terms, the term on the right, we divide it by the term on the left, and we get the same value, the same quotient value, then it means we have a geometric progression. That common ratio, the answer to the division of consecutive terms, that is designated R. Of course, the first term, the first number in the list, is called the first term, which is represented by the variable a. And we have expressions to find any given term in the list. Once we have the common ratio R and we have the first term, it means we can calculate any number which is, we can find any number which is on the list of a geometric progression, or the sequence of a geometric progression. So let's take a look at one or two examples and see how we can calculate the GP. There's an example which says for the geometric progression 25, 1 1/4, find the common ratio, find the nth term, and find the sum of the first 8 terms. Alright, so our GP has the first number, which is 20, the second number is 5, the third number is 1 1/4, 1 1/4, and the list goes on. Okay, the sequence continues after 1 1/4, it doesn't end there. So from this list, we know the first term, the first number in this list, which is designated A, is 20. Okay, the first number in that sequence is 20, and we can get the common ratio R by dividing consecutive terms. So we can divide 1 1/4 by 5, we'll find an answer, or 5 by 20, we'll find an answer. So you'll be able to find that when you divide 5 over 20, or 1 1/4, which is 5 over 4, by 5, when you do that division, you'll be able to find that your common ratio is 1 over 4, or 0.25. 1 over 4 or 0.25. So that is our common ratio. The second part of the question, the first part was simply to find the common ratio. So R there is 1 over 4 or 0.25. The second part says we find the nth term. So we can find the nth term, which we can say Tn. We have got the formula which says A R and then n minus 1, R to the power n minus 1. In which case we have A is 20, A is the first term, so A is 20. Then R is 1 over 4, and that is being raised to the power n minus 1. Okay, so the n is simply representing the number of terms. So in this particular example, we can simplify and say 20. 20 is multiplying. Now, according to indices, when you have a fraction that is sharing the same power, the same index, we can as well split the power into the numerator and the denominator separately. So in short, we have n minus 1, 1 to the power n minus 1 over 4 to the power n minus 1, according to the laws of indices here. Okay, the index of a fraction is equal to the index of the same index split into the numerator and the denominator. So now the numerator gives us an interesting value here, because n is any positive number starting from 1, because 1 represents the first term, 2 represents the second term, 3 represents the third term. So n can only be 1 or more, right? Because it cannot be a negative number, because we are just counting the number of terms in the GP. So because n, the smallest value of n is 1, it means the power of 1 can only be 0 or more. Okay, it can only be a positive integer including 0. So which means whatever power of 1, it can only give us 1, because 1 power 0 is 1, 1 power 1 is 1, 1 power 2 is 1, 1 power 1000 is still 1. So in short, our numerator is simply 1, which means when we multiply it by 20, we'll have 20 there, so that the 20 becomes our numerator and the denominator is 4 to the power n minus 1. So this is the formula for our nth term. This is the formula for our nth term. We can confirm the position of the first 3 terms, for example. We can find if the first term is 20, so it means where there is n in that formula, if we put 1, we'll have 4 to the power 1 minus 1. 1 minus 1 is 0, so 4 to the power 0 is 1, which means 20 divided by 1, and 20 divided by 1 is 20. To confirm the second term, it means where there is n, we put 2. Second term. So where there is n, we put 2. And 2 minus 1 is 1. So it means 4 power 1, which is 4. So 20 divided by 4 is 5, which is correct. If we put the third term, it means where there is n, we put 3. 3 minus 1 is 2, and 4 power 2, which is 4 squared, is 16. So our fraction will be 20 over 16, and 20 over 16 simplifies to 5 over 4, which is the same as 1 and 1 over 4. So that confirms that that is the correct formula for the nth term of this particular geometric progression. Now, the last part of the question is for us to find the sum of the first 8 terms. So since our error is 1 over 4, or 0.25, which means error is less than 1. So we are going to use the formula in which we are taking error which is less than 1, which means we'll use the formula sum of the first 8 terms will be equal to A is our first term, which is 20, times, in brackets, 1 minus error. Error is 1 over 4 or 0.25. 1 over 4 or 0.25 to the power 8. We are finding the sum of the first 8 terms. So it means we have that expression. Since our error is less than 1, it means we have here 1 minus 0.25. Okay, so now we are just using 0.25 as a convenient value, but you still get the same answer if you use the fractional form of the number, which is 1/4. You can use 1/4 and still get the same answer. So now we have on the numerator part, we have 20 times 1 minus 1 minus now 0.25 to the power 8. 0.25 to the power 8 is an extremely small number, which may look something like that: 0.000015258. So even if we are to round off to 1 decimal place, 2 decimal places, 3 decimal places, it is still giving us 0. So in short, that is 1 minus 0. Then here on the denominator we have 1 minus 0.25, that is 0.75. So in short, on the denominator we have 20 times 1 minus 0 is 1, so 20 times 1 is 20 over 0.25, sorry, 0.75 and 20 divided by 0.75 gives us 26.7 or 27. 26.7 or 27. It's 26.666667. So we can round it off at the nearest whole number or 1 decimal place to have 3 significant figures. So that is how we solve questions involving the geometric progression.